On this page, we're going to learn how to verify inverse functions algebraically. This specifically has to do with functions. The previous page, we are looking at how we can tell if we have inverses graphically. That we saw that the graphs were reflections of each other in the line y equals x, and numerically we'd be switching inputs and outputs. But algebraically, there's a formal process that we're going to use, and what we're going to use to verify inverse functions algebraically is actually composition. So up here at the top, if we have an input x goes into a function named f, what comes out is f of x. Right? That's how functions work. If we then take that f of x and we put it into the inverse function, f inverse of x, what's going to come out is f inverse of f of x, the composition. But since f and f inverse are inverse functions, they undo each other. What's going to come out when we compose with f inverse is just what we started with, which is x, right? Because f inverse here is going to undo f. So we're going to result in what we started with, which is x. So we can say that f inverse of f of x is equal to x. They undo each other. This is actually the definition of the inverse of a function. So if functions f and g are, this is how we can verify them. Functions f and g are inverses of each other provided that f of g of x equals x and g of f of x equals x. So we're going to use composition to verify that functions are inverses. Okay, this is the only way that you're going to verify that functions are inverses. Later, we're going to learn how to find inverse functions, but that's not how we verify it. You must verify using composition, and you must do the composition both ways. You must compose f with g of x and g with f of x. Okay, with this in mind, we know that we already stated that inverse function switches x and y values of the original function. With this in mind, we can conclude that the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. Okay, now, example 4, we're actually going to practice using composition of functions to verify algebraically that f and g are inverses. So the only way to verify that functions are inverses is to use composition. So to do that, we need to find out what f of g of x is and g of f of x. So first, let's do f of g of x. So f of g of x is going to be f of g of x is this function here. So 1/7 x plus 4/7. When we're doing composition, that means that we're going to take this 1/7 x plus 4/7 and substitute it in for x in our original function. So we're going to have 7 times 1/7 x plus 4/7, and then minus 4. We'll distribute the 7 here, so we'll get x plus 4 minus 4, which equals x. We're halfway there. We've shown that f of g of x equals x. We also have to show that g of f of x is equal to x. So we're going to find g of f of x. If we, and we'll do this step now. So we're going to do g of f of x. So here f of x is 7x minus 4, which means that everywhere we have x in the g function, we're going to substitute in 7x minus 4. So this is going to give us 1/7 times x becomes 7x minus 4, and then plus 4/7. We'll distribute the 1/7. So that gives us 1/7 times 7x is going to be x. And then 1/7 times negative 4 is going to be minus 4/7. And then plus 4/7, which is going to be x. So we have now shown that g of f of x equals x. So we've done the composition both ways. And now after this, we can conclude that because the composition worked both ways, we got x, we can say that therefore f of x and g of x are inverse functions.